Hello again, and welcome to another program of the week from Camp Insights. This week, we're going to do a program to demonstrate the idea of modular programming. That is, breaking just about everything out into its own little procedure or function that is written separately and can be maintained separately. This program is inspired by a real life problem that sometimes you need to uh, buy new carpet or new floor tile or something, or in my case, we just needed to bring somebody in to help clean the house for a special occasion, and they needed to know how much floor space they were going to clean. Um, so you need to go room by room and figure out um, how wide the room is, how long the room is, and uh, estimate the total square feet that you're going to need to the total square feet of carpet or flooring or total square foot that somebody's going to clean or whatever. So that's our problem today is the floor space problem. So we have three main tasks here. Um, we need to get the number of rooms. Okay. Um, then for each room, we need to get the square feet of floor space. Then we need to print the total square feet for the house. Okay. Now I could write all of this in int main if I wanted to, and that's kind of been the way we've been writing programs. Or it's the way you sort of start writing programs if you're a new programmer. Um, but it's better to write your programs in a modular fashion where you break out different things into their own functions so that each function is easier to maintain and it's easier to isolate bugs as they come up, and it's easier to reuse your code someday as well if you need to. So let's, instead of writing code here to get the number of rooms, I'm going to say int, because the number of rooms is going to be a whole number. We don't have partial rooms. Um, we're going to say int um, num rooms equals get rooms. Okay. Now guess what? In just a moment, it's going to come up with a little undeclared identifier get rooms. Yeah, I haven't written that function yet, so of course it is still unidentified. Okay. Um, and I could click the little X to make that go away, but I'm going to leave it there to remind myself that I need to write that function. Then for each room, get the square feet. Well, okay. We're going to have, we need an accumulator variable, something to hold the total square feet. So um, in this case, we're going to use doubles because the total number of feet could be a fraction, could be have a decimal point in it. So double tote area equals 0.0 to start with. Then we say for. Why am I using a for loop? Well, because we know how many rooms there are. We've already gotten that information. So it's a simple matter of counting up rooms. For int room equals 0, room less than rooms, room plus plus. Now you may ask, why did I start at 0 and not 1? I could have done this int room equals 1 room less than or equal to rooms. Okay, I could have done that and it would work just fine. The reason we always start for loops at 0 in C++ and C family languages is something you'll learn in the next lesson when we get to arrays and vectors. When you have a list of things in C++, it always starts counting at 0. So if we wanted to keep a list of the rooms with the areas for each room so that we could print out each room at the end of the um, uh, program, we'd need to start counting from 0 and then go up to 1 less than the number of rooms. So that's why C++ for loops almost always start at 0, unless you have a good reason not to, as in my for loop for doing the degrees Fahrenheit to Celsius that we did last time. Okay. So all we have to do here now is say tote area plus equals get area. Okay. This is what we call modular programming. Okay. It also makes my main program really easy to read. I'm going to get the number of rooms. I'm going to get the area of a particular room. In fact, I might need to tell the get area function which room I'm getting the area for. Okay. And then when we get down here, I could write a single cout statement, but again, keeping with my modular programming theme, I'm going to say print area tote area. Okay. So now I've got three undeclared identifiers for my three functions that I'm going to need to write up here. Okay. So we now come up before int main and we go ahead and write these three functions. Get rooms we know is going to return an integer, so it's int get rooms, and it doesn't take any parameters. And all it's going to do is it's going to say cout how many rooms are we adding up. Okay. Then I create a temporary variable rooms. I cin rooms, and then I simply return that value to the calling function. And now I can run this and I can find out if my get rooms works. I could have a little stub of code here that just prints out the value of num rooms to make sure that my get rooms function works. Okay. And I could comment out the rest of the program and I could just test that one function. And that's a very good way to do your programming, is to write a little code and do a little test and then go back to writing a little more code. Because if you write all the code at once and then you try to test it, who knows which part of it is broken, right? Okay. In this case, I have already written this program and tested it, so I know it's going to work. But in your case, you really should stop here, test it, and then go on with the next little bit. Okay. So get area could return, a fractional number. You could have half a square foot. So we're going to have double get area. But we're going to have int room. Okay. And so we're going to see out what is the width of room plus 1. Okay. Why do I add 1 to room? Because the person who's using the program probably does not think in terms of 0 indexed lists. And so the first room would be room 0, and they'd be like, what? Room 0? I don't understand. So we're going to add 1 and count up that way. Then I have double width, because the width of the room could have half of a foot or a third of a foot or something like that. I'm going to CN width. Then I'm going to simply copy this and paste it for length. Okay. Now, we're assuming that all the rooms in your house are perfect rectangles. That's obviously not a great assumption, but it's close to true for most houses, so or apartments or whatever. So we can go then and say the formula for area for a rectangle is width times length, right? And then I just have to return area. All right. So again, we could stop here. We could do a couple of rooms that are easy to figure out, like 10 by 10 and 5 by 5, and see what we come up with, and make sure that that function works properly. And then we have one more function called print area. Now, print area does not return a value, so it's a void function. But it does take a value for area. And we're just going to see out here total area equals area square feet. Of course, we don't know that the person is measuring in feet. Nothing in our program has specified that it has to be in feet. They could be measuring in meters, so this could be square meters. So let's go with, say, square units. And then we inline. Okay. All right. Now, we've written the entire program. Let's see how it runs. Drag this up a little bit here. How many rooms are we adding up? Let's say 3. Okay. And we'll say that the first room is 10 by 10. So that should be 100 square feet. Now my next room is, say, 5 by 20. That should also be 100 square feet. So we should be 200 now total. And then room 3 is 5 by 7. So that's 35. So we should be 235 square units. Yay, the program works. Okay. Maybe it's not the most beautiful looking program in the world. We could add some spacing in here between, before total area, put in a backslash in there to give us an extra space between. And put another one there. But really, it works. And that's the main thing we care about here. So what you've learned from this program of the week, we've learned how to write functions that take input. We've learned to write functions that calculate a value and return that. We've learned to write functions that print output. We've learned about return values being int or double or void if you're not going to return anything. And we've learned how to use functional programming, or not functional programming, modular programming. Functional programming is a slightly different thing. To make this the main body of our program very easy to read and very simple to follow and simple to debug. And finally, we've learned a philosophy of writing a little bit of code at a time and testing it, another little bit of code at a time and testing it, rather than trying to write the whole program at once and make sure it works. So, that's it for this week. Thank you very much for your attention. And as always, until next time, good luck and happy programming.